Hello, so we're starting chapter 4.5, which is simply called Extrema. And extreme values are the points at which a graph achieves its lowest or highest values. Okay, do not include ends that approach infinity. So here's an example. This is actually question 1 from your homework. The absolute minimum is at 1 when x is equal to 1. And you can see that point right there. And then the absolute maximum is at 8 when x is equal to 5. In other words, 1 and 8 are the y values for these x values. This cannot be considered the absolute maximum point, not absolute maximum, because it does not terminate. In other words, if this coordinate were larger, that end of the graph would keep approaching infinity, terminate, while this end stops at y is equal to 1 and x is equal to 1. Next, we want to talk about the extreme value theorem. The extreme value theorem says that a function f is continuous on a closed interval described as a and b, and it's closed, so it's got brackets. And let's function f that is continuous on a closed interval, that is, there's no breaks in the graph, has both an absolute min and absolute max on that interval. hope this is clear here, because what's happening here is that if we were to restrict a graph, say between 2 points, say this is our graph, and we restricted it between A and B, then the point A would be the absolute, in between A to B, the point A would be the absolute minimum, and the point B would be the absolute maximum point. So that's what the extreme value theorem is telling us. Now further, absolute value, absolute extrema, if they exist, must occur at critical numbers or endpoints. So the steps for finding extrema on a closed, I'm still getting used to this pen, closed interval. Step 1, check to ensure it is continuous on the interval. That's important. It must be continuous. And you would either be told this in the problem, or you would have to determine for this yourself. Most of the time, if it is a polynomial, it is already considered to be continuous. Find the critical numbers on the open interval A, B. Evaluate f at the endpoints A and B, and at the critical numbers found in step 2. Absolute max is the greatest value, and absolute minimum is the smallest value. Now, all these problems are substitution and just calculating when we after you find the critical numbers, all we would need to do is substitute numbers. This is from number 3 in your book. We're given this function f of x is equal to 4x squared minus 7. This is a polynomial, so we already know that it's continuous. The interval given is between 4 and 5, the closed interval given. Okay? And we already established step 1, polynomial, so continuous on AB, the given interval. And next we would take, because we have to find critical numbers, so we would go ahead and take the derivative of the function f prime x is equal to 8x. And if we set 8x equal to 0, we get x is equal to 0. However, this cannot be a critical number since it is not in the interval 4 and 5. Okay? 0 is not between 4 to 5. So the only thing we have are 2 endpoints. So we need to compute f4 and f points. We don't have any critical numbers here. So substituting, and remember that you're substituting in the original function. So this is 4 times 4 squared minus 7, which is 64 minus 7 or 57. And then substituting 5, we have 4 times 5 squared minus 7, which is 93. So this is the absolute minimum at 57 when x is equal to 4, and absolute maximum at 93 when x is equal to 5. So now we're going to go ahead, and the problem extends to a different interval, b. The interval given is from -5 to +5. From -5 closed interval to +5. And we already know this is continuous, and we know that f prime x is equal to 8x, so 8x is equal to 0, so x is equal to 0. So this, in this case, x is a critical number. And it's a critical number because 0 is located between negative and +5. Since 0 is in the open interval -5 to +5. Remember, we're not talking about endpoints here. So we have to test 3 things. We have to test -5, 0, and +5. So testing -5, we're still testing the same thing. 5 times this is 4 times -5 squared minus 7. And we know that if we square -5, it becomes +5. So this is equal to 93 also. And we know from the previous part that f5 is equal to 93 also. And then substituting 0, we have 4 times 0 squared minus 7 is equal to -7. So This graph has two absolute maximums. Absolute max at 93 for x is equal to -5 and +5. And the absolute min at -7 for x equal to 0. Question 4 from, I'm doing question 4 from your homework. This is f of x is also a quadratic function, x squared minus 4x minus 5. And this is on the interval 0 to 5. Polynomial, so continuous. And we need to find the prime. F prime x is equal to, taking the derivative here, this is 2x minus 4. And then setting 2x minus 4 equal to 0 gives x is equal to 2. So 2 is on the interval, is in 0 to 5. So that is clearly the critical number, one of the critical numbers. So we need to substitute values now. The endpoints, f0, the critical number 2, and then the other endpoint 5, into the original function. So substituting in 0 in there, we get -5. Substituting 2 in here, we get 2 squared minus 8 minus 5, which is equal to -9. And substituting 5 in here, we get 5 5s are 25 minus 20 minus 5 equal to 0. So the absolute maximum, 0 is the largest number here, because negative numbers are smaller than 0. So absolute max at 0 for x equal to 5. Or not 4, when x is equal to 5. And the absolute minimum point is the lowest value here, -9, at -9 when x is equal to 2. Now, if we consider a graph that is on an open interval, perhaps f of x is equal to x squared minus 8x plus 3, and we're not given endpoints here. We're not given the interval. We know that it's continuous since it's a polynomial. So this graph is open. It's approaching infinity on the two ends. So it would have one minimum point. And since this is a quadratic function, and that minimum point, absolute minimum point, is actually the vertex. So remember that to find vertex now, we simply take the derivative. We get 2x minus 8. Set 2x minus 8 equal to 0 gives x is equal to 4. And then substitute 4 into the original function. We have 4 squared minus 8 times 4 plus 3, which is equal to -13. In other words, that vertex is located at 4 and -13. And this is the absolute min at -13 for x equal to 4. No absolute maximum, since this graph is open on the two ends. Question 6. So we've got f of x equals to x plus 14, x minus 7 squared. And we have to find the min and max on 0, closed at 0 to infinity. So the first thing we want to do here is take the derivative. You can either FOIL all of this out, or you can use the product rule. This is the product rule of u times v. So I'm going to go ahead and use the product rule here. The derivative of the v function is the derivative, bring the 2 to the front, reduce the power by 1, and then take the derivative of the inside, which is 1, times x plus 14, the u function. And then write this function here, which is x minus 7 squared times the derivative of this, which is 1. So x minus 7, you can FOIL that out. That's x squared minus 14x plus 49 times the derivative of this first function, which is 1. So we would need to FOIL this part out also. This is x squared plus 7x minus 98 plus x squared minus 14x plus 49, since we're timesing it by 1. Okay, remember this part here is x minus 7 squared. For distributing the 2 here, I have 2x squared plus 14x minus 196 plus x squared minus 14x plus 49. And then collecting like terms, we have 3x squared minus 147. 196 plus 49 is 196. This 14x cancels out. And 196, negative 196 plus 49 is 147. So we need to set this equal to 0. So 3 into x squared minus 49 equal to 0. And right there we can see the difference is squares. So x squared minus 49 is equal to 0. So x is equal to plus or minus 7. And those are the critical numbers. Okay, so we can set up our... Now, we wouldn't consider negative 7 because this goes from 0 to infinity. And only positive 7 is in this. So only critical number in 0 to infinity is x is equal to 7. So the only two numbers that we need to test are f0 and f7. Substituting 0 into this function, I'm going to leave that up to you guys. This is 0 plus 14, so this is 0 plus 14, and then 0 minus 7 squared. So this is 14 times 49, which is 686. And then substituting 7 into this function, we have 7 plus 14, 7 minus 7 squared, which is 21 times 0, which is 0. So here you can see we have an absolute maximum at 686 when x is equal to 0, and an absolute min at 0 when x is equal to 7. I hope you guys can see the extreme value theorem here work, that it must have an absolute minimum and an absolute maximum so long as it's inside of that closed interval. One last problem for this section. This is actually question 7 in your homework. Here we're given this function f of x is equal to 17 minus 4x minus 16 over x on the interval 0 to infinity. So this is 17 minus 4x minus 16x to the power negative 1. I'm doing that because we're going to need to factor this. And you can put that into your calculator and check to see that it's continuous on this interval. The only part that would not make it continuous is that x is equal to 0. So x cannot equal to 0. So they're giving us an open interval on both ends, right? X cannot equal to 0 here. That's why this 0 is not in brackets as a closed interval. So f prime x is negative 4. Negative 1 times negative 16 is positive 16x to the power negative 2. And if we set this equal to 0, well, we can probably factor out negative 4 here. We would have 1 minus 16 x squared, x to the power negative 2 is equal to 0. So we would just need to set that part inside of the parenthesis equal to 0. 1 minus 16 x squared is equal to 0. I think this is if I factored out here, I would have 4, no, not 16. Yeah. So this would mean that 4x squared, okay, I kind of messed this up here. This is 1 minus 4x to the power negative 2 is equal to 0. So negative 4x to the power negative 2 is equal to 1. Right, if we move the 1's to both sides, this would be positive. So this means that 4 over x squared is equal to 1. So x squared is equal to 4. So x is equal to plus or minus 2. Again, we can't consider negative 2 because negative 2 is not in the interval 0 to infinity. So the only critical number is x is equal to 2, since negative 2 is not in 0 to infinity. So we're going to be testing two and to see where the absolute minimax is. Remember, x cannot equal to 0 either because 0 is not included. So the only thing we'll be testing here is f2. So substituting 2 here, I have 17 minus 4 times 2 minus 16 times 2 squared, which is 17 minus 8 minus 8, which is positive 1. So this, since this is the only value, we would have, in 0, we can't have 0 into the calculator. We're going to have to, we can't have 0 here. We're going to have to check this with the calculator. This is the absolute maximum at 1 when x is equal to 2. So I'm going to pause this and open up the calculator because I need to check it. Let's go ahead and pause it